that information from the universe is brought to us by multiple messengers. Not only light, but also gravitational waves, cosmic rays, and neutrinos. Observations of the most violent transient events, using all messengers and across the electromagnetic spectrum, from very high energies down to radio, are collected and made accessible in one place, the Astro-COLIBRI platform. These observations are carried out by researchers using satellites and ground-based telescopes worldwide. They are also contributed by amateur astronomers using their own equipment. Together, they enable real-time monitoring of the transient sources with the Astro-COLIBRI platform. Welcome to this new tutorial, where we will discuss useful features for optical transients. Today, we will focus on how to use subfilters and how to access the photometry summary for both classified and unclassified optical transients. Let's begin by selecting optical transients, including both classified and unclassified ones. By keeping the button clicked, we can access the list of available subfilters and make our selection. For example, we can set the detection magnitude as equal to, different from, greater or lower than our preferred value. We can make the same kind of selection for the last observed data point with the facility we want. For classified optical transients, we can access an additional subfilter and select which type of classified transient we want. As an example, let's have a look at novae. We can select a time range to see all the novae included within it. And get the list here on the left. Let's choose AT 2025 AGMM. On the plot, the light curve of the source is displayed. It shows photometric data collected by different instruments and in different filters. In this case, you can see observations from the ZTFG and R bands, as well as the Atlas C and O bands. But what if you want a quick overview of these photometric measurements? This is where the photometry summary becomes especially useful. It provides a quick and informative overview, including the first and last data points, as well as the magnitude at peak. In addition, information on the fading rate is shown. This helps us understand how quickly the source is fading, and in some cases, estimate how long it may remain observable with a given observatory. That's all for today. I hope this tutorial was useful, and thank you for watching. If you like this type of content, remember to subscribe and turn on notifications. See you in the next tutorial.